Hello everyone. Welcome to the solution of LeetCode problem 1888 named minimum number of flips to make the binary string alternating. In this problem, we are given a binary string S. Now, you are allowed to perform two types of operation on the string in any sequence. Now, the type 1 operation is we can remove the character at the start of the string S and append it to the end of the string. And the second types of operation is we can pick any of the character in the string S and flip its value. That means if the value is 0, we can make it 1, or if the value is 1, we can make it 0. Now, we have to return the minimum number of type 2 operations we need to perform such that the string S become alternating. Now here, the string is alternating if no two adjacent characters are equal. For example, the string 010 and 1010 are alternating because here none of the two adjacent characters are equal. But the string 0100 is not, because here these two zeros are equal and they are adjacent. Now, I hope you understood the problem statement. Now the example are here. The string is 111000 in the first example. Now, if we use the first operation 2 times, then we can shift the first 1 into the last of the string. So it will become 100011. Now, if we flip this 0 to 1 and this 1 to 0, the string will become 101010, which is a alternating. So here we have to perform the number of 2 operation of type 2. That's why we have to return 2. But here in the second example, the string is already given alternating, so we don't have to perform any operation here, so it will be 0. Now, in the third example, the string is 1110. So here, if we alternate this 1, and the string will become 1010. So here, we have to perform the 1 number of operation. That's why we have to return 1. I hope you understood the problem statement. Now let's move on to the algorithm. Now, let's understand the first operation. In the first operation, basically, we can pick a character from the start of the string and we can simply append it to the end of the string. So here, we can append the 1 here. Now our string is becoming this. Now here, we can perform the operation one more time. That means we can pick the start of the string 1 and append it to the last position. That means it will become 1011. So what this first operation do? Here, the first operation basically adding any of the prefix to the end of the string. Suppose if we perform the first types of operation 2 times, it will add the prefix 11 to the end of the string. Now our string will become 1011. This is the first intuition. Now, the second intuition is we have to make the resultant string alternating. That means if we can somehow make the string either 0101 dot 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 or 1010 dot dot dot, then the result will be calculated. That means for the alternating string, the resultant string can either start from 0 or it can either start from 1. Now, it is the second intuition. Now, what is the final intuition? The final intuition is, suppose our initial string is here given 1110. Now, let's say it is a barrier. Now here, let's add 1110 once again, which is the equal to the initial string. Now, if we shift the first character one time, the resultant string will be this. This one will be replaced here. Now, if we shift the first to 1, the resultant string will be this. This first to 1 is exactly equal here. Now, if we shift the first 3 1, the resultant string will be this. This first 3 1 will be into this position. Now, if we shift the entire string 4 times, then our resultant string will be equal to this, which is exactly equal to the initial string. So this is the intuition. Now let's summarize the intuition. At first, in the first types of example, if we shift any of the first element to the last of the string, we are basically appending the prefix into the suffix position. Now the second intuition is the resultant string can either start from 0 or it can either start from 1. And the third intuition is, if we add the resultant string, the original string with the original string, then we can easily perform the calculation, because by shifting a fixed size of window, we can find the string after the first operation. Here, if we perform the first operation 2 times, then these 2 1 will be discarded and the resultant string will be this 1011. So these are the basic intuition. Now let's see how can we basically solve this problem by using this intuition. Let's erase it. Now here our given string will be 1110. This is the barrier. Now let's append it once again. It will be 1110. Now our resultant string can either start from 0, so it will be 0 1 0 1 0 1 0 and 1, or it can be start from 1, which will be 1 0 1 0 1 0 and 1 0. Now let's take a fixed size of window. So here let's assume it is the first window size. So here I can either make this given string into this form. I can make it either 0101, or I can make it either this form, which will be 1010. Now let's see what is the difference if I make the initial string to the first type of string. So here these two characters are different, and these two characters and these two characters are different. So in total there are 3 differences. And for this second type of string, the difference is only here, because this 1 is not equal to this 0. So here there are one types of differences. Now, if for the first window, the first difference value will be 3 and the second difference value will be 1. That means if we want to make the string 0101, we have to shift 3 bits. Otherwise, we have to shift 1 bits if we want to make the string 1010. Now, let's shift our window 1 unit to the right. Now our window is this. That means we have shifted the first one into the last of the string. So here, before that, we have calculated the differences into this position. So we don't have to calculate the difference here. As the window shifted, so this calculation will be reset. So here, 1 and 0 is different. So we have to decrease 1 here. It will become 2. And 1 and 1 is equal. So 1 will be same as it is. Now, this 1 is not equal to this 0. So we have to again reset the difference is 3. And this 1 is exactly equal to this 1. So the difference 1 will be remain as it is. So in this second window, for the first string, the 3 differences are this, this, and this. These are the differences. I hope you understood how these 3 came from. So for the second window, the first string difference will be 3 and the second string difference will be 1. Now, let's shift the window 1 unit once again. So here, again, we have to reconsider this column value. So here, 1 and 1 are equal. So we don't have to decrease the value 3, but 1 and 0 is not equal. So we decrease the value 1 to 0. Now again, these two 1 are equal. So 3 will be remain as it is, but this 1 and 0 is not equal. So we have to increase the value 1 here. So it will become 3 and 1 for the third window. Now, for the fourth window, we have to again reconsider this column. So here, 1 and 0 is not equal. So we have to decrease 3 by 1 and 1 and 1 are equal. So we don't have to do anything here. And 1 and 0 is not equal. So we have to increase the difference, which will be 3. And 1 and 1 is equal. So we don't have to do anything here. So for the fourth window, the differences will be 3 and 1. Now for the final window, let's calculate what is the difference. So here we have to again reconsider this column. So here this 0 and 1 is not equal. So we have to subtract 1 from 3. Now 3 will become 2. And this 0 and this 0 is equal. So 1 will be remain as it is. Again, this 1 and this 0 is not equal. So we have to increase 1 from 2. And this 0 and this 0 is equal. So we have to remain 1 as it is. So for the fifth window, the value will be 3 and 1 as well. So here, final answer will be the minimum of all this value. So what is the minimum of all this value? It will be 1. So here, the final intuition is, let's see for this window or for this window, if we shift this bit to 0, and it will become 1010. So here, we have to perform basically 1 unit of type 2 operations. And this is how we're going to solve this problem by using a sliding window technique. We will simply take a window and shift the window to the right side, and simultaneously we will calculate the result. I hope you understood the algorithm, and the overall time complexity of this problem is big O of n. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named beanflips with a parameter string s. Now, we are taking some of the variable answer 1 and answer 2 initialized with 0. And our string s will be duplicated. It will be s plus s. Now, we are building the string s1 and s2. s1 start from 0, s2 start from 1. Now, we have to run a loop from 0 to the size of the s. And here, if the ith character of s string is not equal to the first type, s1, we have to increment the answer 1 value. And if the string value s is not equal to the s2 string, we have to simply increment the answer 2 values. Now here, if the value of I is greater than n, that means we can perform the first type of operation, or alternatively, we can say that we can add any of the prefix to the suffix position. So here, we have to simply decrement the previous value. Here, if the s of I minus n is not equal to s1 of I minus n, we have to simply decrement the answer 1 value. And if the s2 of I minus n is not equal to s of I minus n, we have to simply decrement the answer 2 value. Now here, if I is greater than n minus 1, that means in this case, we can calculate the answer, or we can calculate or consider a window. Here, the result will be minimum of result and minimum of answer of 1 and answer of 2. Finally, we have to return the result. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.